If we have two numbers, a and b, then a common multiple of these two numbers is a number that is a multiple of both a and b. So for example, if you have the numbers 2 and 3, then 6 is a common multiple, since it is a multiple of both 2 and 3. And the same holds with 12, for example, since it is a multiple of both 2 and 3. And there are infinitely many common multiples. But we can talk about the least common multiple. In this case, it's 6. So we can talk about the least common multiple. And we'll denote that by LCM. So what is the least common multiple of, for example, 3 and 4? Yeah, multiples of 3 are these. And so on. And the multiples of 4 are these numbers. So we see that they have some multiples in common. And the smallest one we find here now is 12. So the least common multiple is 12. Of course, there are infinitely many, but the smallest one is 12. So the least common multiple of 3 and 4 is 12. Then we also can talk about common divisors. So what is a common divisor for two numbers? For example, if you have two numbers a and b, then the common divisors are numbers that divide both a and b. So for example, if we have 18 and 30, then which numbers divides these two? 18, 1 of course, trivially. 2, 3, not 4, 5, 6 is the next one. Then not 7, 8, 9 divides. And 18. And the divisors of 30 is 1, 2, 3, and not 4, 5, 6. Then 10, 15, and 30. Okay, so we have a lot of common divisors. For example, we have 1, but that's trivially. So 2, 3, 6. So that's the common divisors. But then we can talk about the greatest, or the largest, greatest common divisor. And in this case, we see it's equal to 6. So we have that the greatest common divisor of 18 and 30 is equal to 6. Okay, so least common multiple and greatest common divisor. We saw that in the previous lecture, how that can be done by, so if you look up here, how that can be done by prime factorizations. If you write the numbers as prime numbers, in terms of prime numbers, then we can find it. But this takes a lot of time and effort to do. And if you have large numbers, then it's more efficient to use what is called Euclid's algorithm. So now we want to show Euclid's algorithm. And to do that, we need a theorem, the following theorem. And so assume that we have that A is equal to K times B plus R. So you have a division of A and B, then we have a quotient and the remainder. And here we have that the remainder is between 0 and B. Then it holds that, according to this theorem, it holds that is we have the greatest common divisor of A and B. So the greatest common divisor of these two is actually the same as the greatest common divisor for B and R. So the greatest common divisor for these two numbers is the same number as the greatest common divisor of these two. So these two and these two have the same greatest common divisor. And that's the content of this theorem. And this is proved in the book, my book, as you see the link in the description. But we will not prove it here now, we just take this result, accept it. So now we want to see how Euclid's algorithm works, and it's founded on this theorem. So let's take a concrete example to show it. Let's say we want to find the greatest common divisor of numbers 80 and 30. So what's the greatest common divisor of 80 and 30? In this case, of course, we can use prime factorization technique. So we just have to think that really we're after when there are larger numbers. But we're after the principle here. So let's do the division of 80 and 30. And what is the quotient and the remainder then? Yeah, the quotient is 2 and the remainder is 20. Okay, but now we know, according to the theorem we just saw, that the greatest common divisor of these two numbers is the same as the greatest common divisor of these two numbers. And that we'll now use. Therefore, according to the method, we now continue by dividing 30 and 20. And then we have a quotient of 1 and the remainder of 10. Okay, so what we have done here now is we have taken this number and it has taken the role of now the number we want to divide with, the dividend, and this is now our divisor. But then we repeat this. Okay, so now 30 and 20 has given us 20 and 10. So now we want to do the same for 20 and 10. So this is the method of Euclid's algorithm. And now we move this here. Okay, what do we get then? Then we get the quotient of 2 and the remainder of 0. And when we come to 0, and we eventually will, then the Euclid's algorithm has stopped here. Then this number here, then that is the greatest common divisor of 80 and 30, the one we're looking for. So we continue in this fashion until we have a remainder of 0. Then the remainder before that, that's the greatest common divisor of the two numbers we were seeking. So this is the method of Euclid's algorithm. So why does this work? Yeah, then we have to use this theorem we had here. We see that the greatest common divisor of these two is the same as these two. So that we have that the greatest common divisor of 80 and 30 is the same as the greatest common divisor of 30 and 20. And those we also have here, 30 and 20. Then again, using the theorem, we see that the greatest common divisor of 30 and 20 is the same as the greatest common divisor of these two. So this is the same as the greatest common divisor of 20 and 10. So 20 and 10. And again, using the theorem, the greatest common divisor of these two is the same as the greatest common divisor of these two. But now we have 0. What is the greatest common divisor of a number here and 0? And that is, of course, the number itself, because everything divides 0. So therefore, we end up with this number here, the next to last remainder. So that's why the Euclid algorithm works, because we get the greatest common divisor there, because here is 0. So that gives you a technique or algorithm to find the greatest common divisor of two numbers. But what then about least common multiple of a and b? So let's say you have found now the greatest common divisor, but you also want the least common multiple. Okay, then you can use the following formula, that this is given by a times b divided by greatest common divisor of a and b. And this is proved in one of the exercises in my books, in the elementary part of the books. So if you look there, you can see the proof of this. So let's just use it here now. So let's say that we want to find out, now we have found out that the greatest common divisor of 80 and 30 is 10. So what about the least common multiple of 80 and 30? Well, then you just take 80 times 30 according to this formula here. Then you divide by 10, since that's the greatest common divisor. So this is 2400 divided by 10, so 240. So that formula will then give you. So you only need Euclid's algorithm together with this to get the greatest common divisor and least common multiple.